Welcome to the module on flexible payments. In this module, we will be talking about the embankment construction, which is the first line of action as far as the construction of roads is concerned. Embankment construction, as you can see, is the bottommost layer of any road cross section. After embankment, you can get subgrade. Over subgrade, you have subbase, then road base, and then the bituminous layer. The basic structures of different layers of a pavement section, whereas except the embankment part, all other layers are defined and have a certain thickness depending upon the loading conditions and the design, whereas the height of embankment varies from location to location. The height of embankment is basically depends upon the original ground level conditions and the fixed or the finished road level required at that particular. If you say embankment, by definition, a road, railway line or a canal is normally raised onto an embankment made of earth to avoid a change in level required by the terrain. The alternatives being either to have an unacceptable change in level or a detour to follow a contour. A cutting is used for the same purpose where the land is originally higher than the required. Embankments are often constructed using materials obtained from the cutting if found suitable for the purpose. Embankments should be constructed using suitable materials to provide adequate support to the formations and long-term stabilities. The photograph shows the construction of embankment work in progress. If you see the specification of the materials to be used as embankment, the size of the material is restricted to less than 75 millimeters. The liquid limit value should be less than 50. Plasticity index of the material to be suitable for embankment should have a value less than 25. MDD, that is maximum dry density, should be 15.2 kilonewtons per cubic meters for a height of embankment less than 3 meters, and maximum dry density should be more than 16 kilonewtons per cubic meters for height greater than 3 meters of embankment. And compaction at any point of time shall not be less than 95% of the lab maximum dry density achieved for that particular type of soil. When we see the cut and the fill sections, anything if the original ground level is higher than the FRL, then it comes under the cut form, otherwise it comes under the fill form. When it is fill, we call it embankment. When it is cut, we call it a part of embankment which is being cut. Now, if you want to determine the number of layers or the number of layers that is required to be calculated in order to get the height of the embankment, what is basically required is you need to know the original ground level at that particular point, the finished road level at that particular point, the crust thickness, which is a constant basically, as because that varies from design to design and the MSA calculations, and then the subgrade thickness, which is a constant of 500 millimeters. So if you deduct the original ground level from the finished road level, you will get the complete height of the cross sections. Out of that, when we deduct the crust thickness and the subgrade thickness, we will get the height of the embankment. Now, if you say if you got a height of embankment say around 1 meters, you know that each layer should have 250 millimeters of layer thickness as per MoRTH. So the number of layers required to reach the required embankment top or to support the cross section to reach to the FRL level is 4. So this is basically a typical diagram showing how the cut section will look like when the original ground level is higher than the FRL or the finished road level, the cross section is supposed to be under the cut section, and if it is lower than the required finished road level, then it becomes fill section, and we call the fill section as basically the embankment of that particular section. Unsuitable materials for embankment, if you see, materials from swamps, marshes or bogs, peat, logs, stumps and perishable materials, any soil that classifies as OL, OI, OH or PT in accordance with IS 1498. Materials in frozen conditions, clay having a liquid limit exceeding 50 and PI value exceeding 25. Materials with salt resulting in leaching in the embankment, expansive clay where the FSI is normally more than 50%. Soluble sulfates contains exceeding 1.9 grams of sulfate as SO3 per liter when tested in accordance with BS 1377 test 10. Other particle size exceeding 75 millimeters, which is not getting crushed by the application of a dozer or grader or roller. These are some of the cross sections showing how the cut section will look like when you have the construction of road work. Again, the FRL is lower than the original ground level. So the original ground level is digged down and it made cut to size to reach to the finished road level at the. The other part which we discuss normally is the borrow area for embankment materials. When the cut material is not suitable or the cut material is not sufficient to complete the construction of road work by filling, we look for the new material, which is basically the borrowed material from the nearby places. Where the materials are to be obtained from designated borrow areas, we specify the borrow areas are not designated by where specified borrow areas are not designated by the employer or the engineers. We make local arrangements to source the supply of material for embankment or subgrade, as well as compliance to the environmental requirements in respect of excavations and borrow areas as stipulated from time to time by the Ministry of Environment and Forest, Government of India and local bodies as applicable shall be the sole responsibility of the contractors. The contractor obtains the representative samples from each of the identified borrow areas and they test the soil samples in their site laboratory to check the suitability of the material for the embankment. Like they check the Proctor values to determine the maximum dry density and optimum moisture content. We do the attributes limit, that is the liquid limit and the plastic limit of the soil, the grain size analysis, and FSI of that particular soil. If the soil meets all the requirements as stipulated in MoRTH, then the soil is made to be suitable for use as embankment work. Then the compilation of the test results is being submitted 7 days before the commencement of the work to the engineers for approvals. The documents necessary to submit are basically the density moisture relationship, the maximum dry density and the optimum moisture content of the soils, and then dry density moisture content and CBR relationship for light, mediate or heavy compaction efforts. The original ground shall be leveled to facilitate the placement of a first layer of embankments, scarified, mixed with water and then compacted by rolling to achieve the maximum dry density as given in table 300.2 of MoRTH. For subgrade and earthen shoulders, the compaction required is not less than 97%. For embankment works, the compaction requirement is not less than 95%. For expansive clays, wherever the presence of expansive clays are there, subgrade and 500 mm below portion, just below the subgrade, the expansive clay materials are not allowed. And in the remaining portion of the embankment, we can go with the expansive clays where the compaction requirement is at least 90%. When we are talking about laying of embankment, the embankment and the subgrade materials shall be spread in layers of uniform thickness not exceeding 250 millimeters. Successive layers shall not be placed until the layer construction has been thoroughly compacted and specified requirements and got approved by the engineer. Each compacted layer shall be finished parallel to the final cross section of the embankments. The compaction shall be done with the help of a vibratory rollers of 80 to 100 kilonewton static. How to calculate the dumping materials, how to calculate how much material is required to construct one layer of soil using one layer of soil in embankment. So in order to do the calculation part, what is required is basically we need to know the compaction factor of that particular soil. That means you need to know the ratio of the rotted weight of the soil with respect to the loose weight of the soil using a density cylinder, which will give you the compaction factor. That means if you place loosely the soil, what will be the weight of the soil in that particular standard volume of a cylinder, and when rodded, what is the weight or the increase in weight in the standard cylinder. So that is the compaction factor which is basically required to be calculated for getting the number of dumpers or the now for getting the material required to be placed for a compacted layer thickness of 250 millimeters. Now what is required is calculate the volume of the earth required for one layer, then calculate the weight of the earth required for the same layer. Once you know the weight of the earth required for the layer, you can get the total weight of the material required considering the compaction factor of that particular soil. That means if it is 20%, say 1.2 times or 1.3 times that factor you need to multiply in order to get the total weight of the materials required. Then divide the weight of the soil carried by each dumper. So you should know that what is the carrying capacity of each dumper for that particular soil. So if you have 100 tons of earth required and your dumper carrying capacity is 20 tons, that means 100 by 20 is 5 numbers of dumpers required for that particular soil dumping at that particular location. So this is how you get the total number of trips of dumpers required to carry the material to your. This is the process of dumping which is being carried out at a project sites using high-bars or big vehicles where you have the capacity of each dumper to the tune of say 20 tons or 25 tons. Then you have an equipment called dozer which dozes the dumped material spread across in order to get the uniform layer thickness. Then the graders do the grading part, which will try to maintain the camber or the levels and line and levels of the material being spread across. Then the water tankers are being used to do the watering of the soil layers being placed before compaction, because in order to compact the soil, you need to compact the soil at OMC or close to OMC, that is +1 or -2, in order to achieve the required compaction levels. Some of the precautions required while laying the embankment are: before starting the compaction, the moisture content of the soil should be checked. Moisture content of each layer of soil shall be in the range of 1% above or 2% below the optimum moisture content determined. After adding the required amount of water, the soil shall be processed by means of a grader, rotary mixers, or otherwise approved by the engineers until the layer is uniformly wet. Clods or hard lumps of earth shall be broken to have a maximum size of 75 millimeters when being placed in the embankment. Earth moving plants shall not be accepted as compaction equipments. When the density measurements reveal any soft areas in the embankment, further compaction shall be carried out as directed by the engineers. If in spite of that the specified compaction is not achieved, the material in the soft areas shall be removed and replaced by approved materials compacted to the density requirements and satisfaction of the engineers. Soft areas, in other words, we also call it as a bumping, because generally this happens because of the entrapped air within the soil mass. So one way to remove is harrow it, open it to the sky so that the moisture gets reduced. If you don't have time to harrow and allow it to dry in atmospheric temperatures, then the other way is you need to remove the complete soil mass which has the entrapped air, and then replace it with the fresh material which is as good as a good approved borrow material. Because without treating the bumping materials, if you are further processing your next layer, Please understand that bumping will have an impact on the upper layers also, even up to the bituminous layers also. So you will have defects on the bituminous layer if not treated the soft areas in time. The surface of the embankment or the subgrades at all times during construction shall be maintained at such a crossfall as will shed water and prevent ponding. So in summary, in this module we talked about the embankment part, how to calculate the number of layers in the embankment, how to calculate the quantity of the dumping materials which is required to make one layer of embankment, what are the necessary precautions which is being considered in order to construct the embankment, the controls required during execution of the embankment work, and compaction requirements for embankment, which is basically 95% of the lab maximum dry densities. In the next module, we will cover the construction of subgrade construction. Thank you very much.